So chapter 6 is all about polygons, okay? Polygons are just different sided shapes. Okay? They go all the way up to infinite amount of sides. Okay? What did we focus on most of the time last semester? Triangles. Okay, triangles are polygons, so you may see a little bit more triangles, but we're kind of going away from them for now. Okay, so what I challenge you with is labeling your paper 1 through 12 and naming those sided shapes. Okay, what's a one-sided shape called?
A line.
Okay, I'm glad some of you said that. Is a circle a polygon?
No.
It's
There's
polygon. Right. A circle is not considered a polygon because it does not have straight sides. Okay? Circle is not a polygon. We aren't to circles yet. So 1, I would agree with a line. Okay? You can't make any shape out of one side. Okay? What about 2? I heard an angle. There's really no shape for number 2. Okay? There's no specific shape for number 2. Okay, the rest of these, there are shapes. 3. Triangle, all of you should have that one. 4. The basic term for it to cover all of them is quadrilateral. Okay, but if you said square or rectangle, you're not wrong. Okay, 5. Pentagon. 6. Hexagon. Yeah, if you don't have these, I would write them down so you have them. Okay, 7. Okay, a lot of people have said that. It's not that.
7.
You're really close. It's a heptagon. 8. Octagon, or Matt thinks stop signs. Right? 9. What did you say?
9.
We're close. Nonagon.
I was close. I don't remember. I had my list.
10. Decagon. 11. It is not 11agon.
It doesn't.
This one's not too common because what we're used to is we skip from 10 to 12 in problems. Okay, they don't use 11 very often. Okay, but this one is a hendecagon. Okay, I'll come back to that one. Number 12. It's something decagon. Close. I heard it. Dodecagon. Okay. Do shapes exist past 12? Let's name them. So if I had 13, what's a 13-sided shape called? That is a very good guess.
Tridecagon.
13.
I'm not kidding.
Is it like every
13. It's every number.
a 14 on?
14 gone.
So they just start.
99 gone.
They just start.
Yeah. Yep. Where does gon come from? Polygon. All of these are polygons. Okay? Polygons are named after their number of sides. Okay? What we're going to see and what we're going to get used to is the variable n. Okay? Write this down. N stands for the number of sides. Okay? So you want to get used to those names so that you know how many sides each shape has. Because in order to solve the problems that we're going to see, you need to know the number of sides. Okay, that's why I went through those. Okay, angles and exterior angles. What does interior mean? Inside. So if I'm looking at this shape right here, interior angles are all of these angles inside of the polygon. Okay, the angles are created by two sides connecting together. Okay. With these, we want to know the number of sides. Okay, so if I count this one, start here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So this one has 14 sides. How many angles is it going to have? 14 angles. Okay. Something I want to talk about is the difference between, you don't need to write this down, a regular polygon and an irregular polygon. We talked about this oh my goodness, there we go. We talked about this very briefly last semester. Okay, there are two different things that classify a regular polygon. What are equal? Yes, angles are equal and sides are equal. Sides are equal, angles are equal. Irregular, what does that mean? They're not. They're a little wonky. Okay, so whenever you see the term regular in front of the polygon, you can assume that the sides are all the same and the angles are all the same. If you don't see that term, you can't assume that. Okay, most of the time it will have that term in front of it. Okay, here's the formula I want you to write down. Interior angle sum formula is this right here. Okay, interior angle sum is 180 times n minus 2. Okay, that equation will help us find the interior angle sum of all the angles on the inside of the polygon. So I'm just going to stick with this shape that I started with up here. How many sides did we say it had? 14. So if I want to find the interior angle sum of that 14gon, how do I do that? I'm going to plug it into that equation. So what's n stand for again? Number of sides. So I take 180 times number of sides is 14 minus 2. What has to happen first? 14 minus 2. So we have 180 times 12, which is 2,160. Thank you. That is the interior angle sum. Okay. I'm going to backtrack for a second. This example that we just did with the 14-sided shape, this was the total angle sum of the interior angles. Okay? Something you may be asked is, how can I find one of the angle measures? Where'd you get 14 from? Yep. You're going to take the total of the angles added together, and you're going to take that sum, divide that by the total number of sides, which is 14. That'll give you one of them. Okay, so if I did that divided by 14, one of the angles would be 154.3. When we get decimals, which you will, okay, when you get decimals, round to 1 decimal place every time. Okay, 1 decimal place. So let's look at the example that you just did. Today we're going to talk about interior. It says, what is the interior angle sum for an octagon? Okay, how do I find interior angle sum? 180 times n minus 2. What's the only thing we need in order to use that equation?
Your n.
Number of sides, which is n. How many sides does the octagon have? 8. So we plug in 8 for n. 180 times 8 minus 2. What happens to happen first? Yep. 180 times 6, which is 1,080. What does this tell us? What's that number mean? That's the sum of all of the interior angles. How do I find one of them? I would take 1,080 divided by the total number of sides, which would be 8, which is 135. Okay, so keep in mind, just by this equation, we can find the total number and we can find one of them. Okay, keep this in mind, in order for this one to be true, the polygon has to be regular. Okay, because if all the sides are different lengths, can the angles be the same? No. Okay, so that has to be for a regular polygon. Two A wants to know the interior angle sum of a 17gon. What are we doing?
Oh, 180 times 15.
Right, we're using the equation. Okay, some of you are shortening this equation, which is totally fine if you do some of it in your head. Okay, I just want you to understand that we are using this equation pretty much the whole time. Okay, in order to use this equation, the only thing we need to know is the number of sides. So I take 180 times n is what? 17 minus 2, so we get 180 times 15. What do you get?
2,700.
2,700. How do I find the measure of one of them? I take 2,700 divided by 2, which is oh, thank you. What am I dividing by?
15.
17.
Common misconception that we've had. Okay, a lot of us just go to this number, but what do we want to divide by? We want to divide by the total number of sides, which is 17. 158.8. I was like, why are you not answering me? Because I'm not dividing by 2. Okay. I do any questions on those two things? Okay. How to find the interior angle sum and how to find one of them. Good? Okay. I want to look at part B. It says each angle of a regular n-gon, so we don't know what n is. Okay. Each angle measures 172.8. It wants to know how many sides the n-gon has. So what we're looking for is n. Whenever we're looking for something, we're probably going to set up an equation. Okay? What is the only information that it gave us? The angle measure, right? 172.8. What does that equal? That equals one angle, right? We want something in regards to n on this side. Let's think back to this process. How? Close. How did we find the total? How do we find the total interior angle sum? This, right? I'm going to even back up any farther. Here is our one angle measure. How did we find that one angle measure? You divided the sum divided by the number of sides. So sum, I'm going to write it like this, sum divided by n. Can we fill in information that describes how we found the sum? How did we find the interior angle sum? We use this, right? Okay, so I'm going to plug that in on the top. 180 times n minus 2. That's our sum divided by n. So there's my equation that we are going to set up to solve for n. Okay? Again, we don't like fractions. How do I get rid of fractions? Multiply by what? Multiply by the bottom number, which is n. So I'm going to multiply by n on both sides to get rid of that fraction. Bless you. What I have left is I have 172.8, bless you, n equals, do you agree on the right side these n's cancel out?
Yeah.
Okay, so I'm left with the top, which is 180 times n minus 2. We okay here? Okay. Looking at this left side right now, can I do anything with that? No, it's just a value right now. What can I do with this side here? Think. What operation's happening? Multiplication. So I can, distribute 180 into both terms. So what that would give us is 172.8n equals 180 times n is 180n. And then 180 times negative 2 is negative 360. Yep. So now this turns into two-step algebra. What should I do next? Say that one more time. Yep, minus 180n. Okay, so I'm taking 172.8 minus 180, which gives us negative 7.2n. What's still left on the right side? Negative 360. Yep. And then what's my last step? Divide by negative 7.2. So n equals 50. Is that what it wanted? Right, it wanted the number of sides. Well, what does n stand for? Number of sides. Okay, so the number of sides is 50. What would I call that polygon? 50gon. Good. One more question with interior angles. Now, using this information, how would I find the total interior angle sum? Right. I could add this number 50 times. Is that fun? No. What should we do instead? I would plug this number back into our interior angle sum equation. Okay. Notice all the connections happening. Okay. One more thing we have to talk about. Go ahead and flip to the next page. We talked about interior angles. Now we're going to talk about exterior angles. Let me tell you, they're a lot easier. Okay. Exterior angles are formed by these two sides if we would extend them out. Okay, so they're talking about the angles on the outside if we extended the sides out. Write this down. The sum of exterior angle measures of any polygon is 360. That's your magic number. Okay, the sum of the exterior angle measures of any polygon is 360. So no matter what polygon you're dealing with or what the polygon looks like, okay, all the exterior angles add up to 360. So a triangle's exterior angles would add up to 360. So would an octagon's. So looking at example 3, it says, what is the sum of exterior angle measures of a 17 gun? What is it? Why is it 360? Right. Why did you not have to do any work to figure that out? Right. No matter what the polygon is, okay, the exterior angle sum is 360. No math happening. Okay? What if I wanted to know the measure of one of those?
360
Right. It's the same thing as the interior angles. I'd take 360 divided by 17. So 360 divided by 17. Again, how many decimal places do I want you to round to? 1. So I get 21.2 if you're following along. Yep. Okay, so if you're ever trying to find one of the angle measures, either interior or exterior, you're just going to divide by the number of sides to give you one of them. Okay? How does the number of sides in polygons relate to the sums of the measures of the exterior and interior angles? Why do we care about the number of sides when we're trying to find interior and exterior angle sums? Why do we need to know the number of sides? That's the only way we can figure it out, right? Using the equation that we use, that's the only way we can figure out the sums. Okay? So what I want you to write down on number 1 is you need to know the number of sides. Need to know the number of sides. Okay. Once you got that, go ahead and try and find the error on number 2 with someone sitting next to you. And do number 3 while you're at it. Do not have to do number 4. So do number 2 and 3. On number 2, is she wrong? What's wrong with it? Okay, I saw some of us say that this is the wrong word. That should say interior. What else did somebody say?
Exterior equals 360.
Right. If they were following the exterior angles, this should be what? 360. If she was looking for interior angles, would she be right? Did she do it correctly? Yes. 3. What is the minimum amount of information needed to find the sum of interior angles of a regular polygon? Number of sides. Okay, or n. Okay. Go ahead and do 5 and 6. Okay, on number 5, it wants the sum of the interior angles. How do I find those? 180 times,
Oh, it times 9. I got it.
right, we'd get n minus 2, right? That's the equation we're using for interior angle sums. What do we need to figure out in order to use this equation? Number of sides. How many sides does that polygon have? 1, 2, 3, 4, 5, 6, 7, 8, 9. It is a nonagon. So all I would do is plug in 9 to our equation here. 9 minus 2. So I have 180 times 7, which is 1,260. That is your answer for number 5. Number 6, what is the sum of the measures of the exterior angles? 360, no matter what. Whenever you see exterior angles, what's the magic number? 360. Okay, last ones we're going to do today is number 7 and 8. Okay, it wants to know the value of y. I'm going to back us up to last semester. If I had a triangle and I said this is 45, this is 63, how would I find the value of x? I would add up and subtract from 180. Where do we get the 180 from?
All sides have angles.
All angles add up to 180. How are we going to solve this one? Why? Right. We have interior angles. Well, we knew the sum of this was 180. How do we find the sum of this?
Oh, your interior angles, and then you can take all your angles minus.
You're right.
Yeah.
So how many sides do we have? There is 7. So how do I find the interior angle sum?
7 minus 2 times 1.
Yep. We plug it into our equation. So I have 180 times 5, which is 900. Is 900 my answer? No. What does 900 give us?
With all those equal.
900 is the sum. Okay. So how do I find the missing angle?
Divide by
If I know all of these other ones.
Add your other side up and then minus 900.
Right. Add up all the sides that you know and then subtract from the total. What do you get when you add up all those? Should get 800. Everyone get 800? Okay. What's 900 minus 800? 100. That is y. So that's your answer to number 7. Now this takes us back to last semester. How do I find the value of x?
180 minus 100.
Y 180.
Because that's what the measurable line is.
Right. It's on a straight line. 2 angles make up that straight line. So we take 180 minus 100, which is 80. That is your value of x. Good.